Let's look at what Cargo actually creates for you. Open your terminal like I've done and create a new project. I've already done that, but I'm just going to show you how we do. Cargo, new, and the name of your project, Hello World. Enter, press enter. This will create a binary project, a project that compiles to an executable. But if you wanted to create a library instead, which is code meant to be used by other programs, you use the following flag, so --lib. Now I've already created my project, hello world. Sorry, it's not hello work, hello world. So now let's have a look at the file structure. So this is the file structure. We have source, src. Under src we have main, and then we have cargo.2ml. So these are the most important thing that you need to know. The cargo.2ml is your project manifest. So it holds your project name, version, Rust edition, and all your dependencies. And src and main.rs, so this is where your code lives. So for a binary project, the file contains your main function, the entry point of your program. The note at the bottom here emphasize the following: Cargo handles everything for you. It creates a directory, initializes a Git repository, and sets up the basic file structure automatically. You don't have to create any of this by hand, so Cargo does it for you. Let's look inside cargo.2ml. This is what it looks by default. We have package. The package section holds your metadata, which is the name, version, and edition. The edition is important because Rust ships new edition periodically. So to improve syntax and fix design decision without breaking all the codes. All code always keeps working, but for new project, always use 2024. It's the current best practice. And dependencies, here we don't have dependencies, but they can look like this. The dependency section is where you add external crates. Here we're adding rand version 0.8, a popular crate for random number generation, sourced from crates.io, the official Rust package registry. We're also adding serde, which is with the derive feature enabled. Serde is used for serialization and deserialization, and it's used heavily in smart contract development. When you add a dependency and run cargo build, Cargo automatically downloads it, compiles it, and links it into your project. The addition note at the bottom, reinforces this. Always use 2024 for a new project, and this is currently what you should do for now. These are some of the commands you'll use, and we have cargo built that I've shown you already. We have optimization, deploy, cargo run, step, cargo test, cargo FMP, cargo clippy, cargo doc, cargo check, and cargo tree. So these are some that you're going to use. Use cargo check during development for fastest feedback loop. So every time you make a change and want to see if your code is valid, you run this command first. It's much faster than a full build. Now let's start actually writing Rust code. Let's talk about variables. And this is where Rust already starts to feel different from other languages. In Rust, variables are immutable by default. That means it cannot be changed by default. That might sound backwards if you're coming from Python or JavaScript. Variable that can't change. How so? But here's the philosophy. Most values in a program don't actually need to change after they set. Making immutability the default prevents entire classes of bugs where a variable gets modified somewhere unexpected. There are 4 ways to bind a value to a name in Rust. Let, immutable by default. So when you write let x equal 5, that variable x cannot be reassigned. If you try, you get a compile error. And then we have let mute, opt-in mutability. When you do need a variable to change, you explicitly say so with let mute. This makes mutation visible and intentional. Anyone reading your code immediately knows this value is expected to change. Then we have const, compile time constants. Constants are always immutable. They require an explicit type annotation, and their values are evaluated at compile time. By convention, constants are written in Screaming Snake case, and you see it in action. Clarity first. Smart contract best practice. Prefer immutable values. When you're writing on-chain logic, explicit mutation makes your data flow easier to audit and verify. An auditor reading your code should immediately be able to see what changes and what doesn't. Let's see in code. Why x is immutable. Y is mutable. We can increment y with y plus equal 1, but if we try to write x equals 6, the compiler will immediately reject with the error cannot assign twice to immutable variable. Notice the constant max retries. So here we're using the screaming snake case. See how it has a type annotation U32 right after the colon. With let, Rust can often infer the type of the variable, but with const, you must always declare the type explicitly. So here in this case, it's U32, type U32, unsigned integer. The best practice at the bottom here, let's actually go there. Start with let and only add mute when you generally need to change the value. In practice, you'll find that a surprising percentage of your variables don't need to be mutable. Embrace that. Immutable data is safer, easier to reason about, and more auditable. And now you can see I have some warning here. There's a yellow warning here. And here it tells me why. Like here it says if this is essential prefix, let's say the warning, unused variable. The warning is an unused variable, so we haven't used x. Same here. A mutable variable reference or pointer. So let's print it. Okay, so we're going to start by printing X. So I'm getting this warning because I haven't used these values. So that's why the warning has been generated. And there's one thing that I forgot to put here. ln. Okay, so let's do that. Cargo run. And you see we've printed out 5. And let's now try to mutate. So we have x equals 6. Or let's just say x equal x. Let's increment x by 6. We're already catching the error, so this is not going to compile. But if we change it here and then we say mute, then it will be able to compile. So let's run it. And yes, we have 11 because 6 plus 5 is 11. So it's working accordingly.